I've put up an equation that you can try to solve for x. You can pause here to try and solve this equation. If you have unpaused, you're probably confused on what the answer is. Let's go through the equation together. The equation says that x squared plus 1 is equal to 0, and we have to try and solve for x. Let's start by isolating x squared on the left side by subtracting 1 on both sides. By doing this, we get x squared is equal to negative 1. Now let's find the square root of both sides so that we can get x by itself. The result that we get is x is equal to the square root of negative 1. Whatever method we use, x is always equal to the square root of negative 1. Our basic arithmetic rules says that it's not possible to take the square root of negative numbers, so that means that x is not equal to anything, right? Well, that is not the entire story. Let's first start with quadratic equations. Quadratic equations are equations where the highest power of x is x squared. They usually look like a times x squared plus b times x plus c is equal to 0. For centuries, mathematicians knew how to solve these equations when the answers were real numbers. But every now and then, they came across cases like our example, where you get x squared is equal to negative 1, and they were stuck. In the 1500s, an Italian mathematician named Girolamo Cardano was working on solving certain equations, which were cubic equations, and the highest power of x is 3. He ran into square roots of negative numbers, and although he called them as subtle as they are useless, he still wrote them down and used them in his calculations. Over time, other mathematicians started to realize that these strange numbers could actually be treated just like regular numbers if they followed some new rules. They decided to define a new kind of number called I, where I stands for imaginary number, and it equals to the square root of negative 1. With this definition, the square root of negative 4 could be written as 2i, and the square root of negative 9 would be written as 3i. These were called imaginary numbers not because they were fake, but because they did not exist on the regular number line. They extended it into a whole new dimension. Now, using imaginary numbers, our equation x squared equals negative 1 has the solution x is equal to I or x is equal to negative I. So instead of no solution, we now have two perfectly valid solutions, just in a bigger number system than we started with. Now you may be wondering, where else can it be used for? Well, Erwin Schrödinger, an Austrian physicist, came up with this equation that uses I in it to represent the wave-like properties of particles in quantum mechanics. Without this, the equation would not model how some particles can behave like waves, making it inaccurate. This is highly complicated stuff, and I'll make a new video on this, but for the time being, without I in this equation, the equation would not show how particles actually behave. Hope you guys have enjoyed this video, and if there are any questions on maths or science, make sure to drop them down in the comments below.